hammies already. So let's just go ahead and talk about this right now and get it all over with. Because actually, y'all shouldn't be worried about anything until next week. But the hammies are already started. Out of each class, I've got one or two that are, I mean, I could teach 2 chapters in a week of calculus, and people are worried about the last day of class. I don't think you need to worry. You need to worry about this test. But anyway, I'm not gonna harp on it. I'm just gonna jump right over here, and I'm gonna first of all, the only one that should be worried about the last day of class is me, as far as information. Okay. All y'all need to do is come to class and write notes and write down dates. Okay. Now, what do I foresee? I foresee us finishing up this test in the next couple of days. Test on Unit 3 or whatever unit. What is this unit? I'm going to say Chapter 5. Test on Chapter 5. I foresee in the next couple of days, I figure I might put up a test tomorrow.
Yay.
Okay. I don't know, when, Miss Hart, when does the homework end?
Technically today, yeah.
Yeah, tonight, so I might extend it another day or two. All right. So that leaves, I think we have at least a week and a half of class left. Tuesday to Wednesday, isn't it?
It's like 10 days, 11 or 9 days now, I think.
Tuesday, Wednesday, Thursday, Tuesday, Monday, Tuesday, isn't that the 23rd? Somebody check to see if next Tuesday is the 23rd.
Next Thursday is the 23rd.
Next Thursday.
I thought 22nd was the last day.
Okay, when is the 22nd? Tell me that.
Wednesday.
That Wednesday.
Okay, thank you. Do y'all know what I could teach y'all in calculus in a 6 days time? If I was a real bad communicator and bad calculus teacher, I could get in another unit. Okay. Now, what do I foresee? All I care about is the following. I want to make sure you understand first and second derivative. First derivative is equal to increasing and decreasing. And second derivative is equal to inflection points. That's going to come out of Unit 2, which we haven't done yet, but I'm going to pick it out. Don't even try to do Unit 2. I'm going to do away with Unit 2 and Unit 4 homework, and I'm just going to make my own homework. It's going to be called Hubert's Unit 2 homework, Hubert's Unit 4 homework. Okay? And I'm just going to test you on those 2 units. It's going to be called a Unit 2/5 test. And then the only thing I care about in Chapter 5 or Unit 4 is I care about you being able to find the area between 2 curves. And I might do a washer. I might do at least one washer because you're going to have to. And I'm glad I got my computer, my new computer, because now I can bring in those 3D pictures. So we're going to have a Unit 2/4 test. Now, a lot of you are already spazzing and saying, he's going to go over 2 units? No. I'm going to go over probably 4 sections. Two sections here and 2 sections there. Now, am I going to give y'all a bunch of theory and how many people attended Wimbledon and what was their addresses? No. These homeworks on these two sections will come directly from me. They're going to be just like the Hubert's homework that I gave you for unit, what, 3?
Chapter 5.
Unit 3? Yeah, chapter, yeah. Did y'all see a difference in those homework problems and the rest of the unit?
I literally just saw it right before class. So
Okay.
I didn't know
Still-
it was below the test. I was thinking you posted it in the files somewhere and I was missing it. So I'll
Well,
let you know.
I did. Did anybody look at the Hubert's homework, integration homework?
I looked at it a little bit.
It looks a lot more.
Okay, tell me what you think versus the other homework.
It looks a lot more straightforward and more to the point than all this other.
Yeah.
Yeah, it looks like you're actually testing us on the content and not trying to make us figure stuff out.
Exactly. That's what I'm going to do with these two. These 4 sections, you're not going to have but 2 homeworks. You're going to have a unit 2 homework and you're going to have a unit 4 homework. Do not do, what is unit 2? Chapter 2, somebody look on the outline.
When is it?
No, what chapter is unit 2? Is that chapter 2? And this is chapter 6, I believe. Somebody help me. Just look on the outline. You don't have an outline, do you?
I don't have a printer, so I haven't pulled it up.
Maybe it's one of those things I should get y'all to print out the first week of class. I don't know if I even got it pulled up. Hold on.
I can get it pulled up. I just don't have a printer at home.
Well, just pull it up and tell me, somebody got one pulled up?
It's loading right
It's
now.
Well,
chapter 4 and chapter 6.
Okay, so this is chapter 4? Okay. All
Yeah,
right,
unit
so
2.
do not do the homework for chapter 4 and do not do the homework for chapter 6. I'm going to delete it probably after class or sometime. You're going to have 1 unit, 1 homework, and it's going to be Hubert's chapter. It's going to be called either chapter 4 homework or it's going to be called unit 2 homework, something like that. And then you're going to have the same one for this. Okay?
So I
Now,
still
you
need
can
to
go
start
ahead and do
with-
this. If I assigned you the chapter 4 homework, you could do that because you can take the first and second derivative. That's not the big deal. Anyway, I am going to I'm sorry. I am going to talk about this up until the last day of class. And the last day of class, this test, this will be called the Unit 2/4 test. And the final exam will start on the 22nd and go until, when's the last day of exams? Y'all supposed to have that on the academic calendar. I think it's the 27th or the 25th. What is it?
I want to say it's the 27th.
Okay. Y'all look. Somebody look on your academic calendar. So you need to put that on your calendar that on the 22nd or the 23rd, it'd be the 23rd, it'd be the day after classes, the day after classes end. I'm going to start the Unit 2/4 test and the final, and you've got 5 days to do both of them. I will probably put up these 2 homeworks in the next couple of days with the test on chapter 5. Okay, now all those people that are worried that there was about 1 or 2 in each class, and I got to do this tomorrow with the 120s. Okay, I hope y'all.
Priority 1 message coming in on secure chat.
I hope your concerns are relieved now. I think a couple of them just wanted me to say, "Oh no, we're not going to have any more classes."
So with the final, is that going to be on my labs as well as with everything like that we've
Yes,
been
I'm
doing?
I'm not gonna do busy work at the end of the semester. I'm giving you everything on it. Yep. I don't know who asked that, but yeah, I'm not a busy work teacher. I don't do busy work just to do it. So I don't want to grade papers just to do it. If it's good enough for you to do online testing throughout the semester, it's good enough for you to do it on the final. And you'll have two attempts, 2 hours. It ain't gonna take you 2 hours. Calculus test, I doubt it will have 25 questions on it. But it will cover everything that we've covered. It's not going to cover those Wimbledon questions, but it will cover like the like the homework questions that I give. You'll have 2 hours to take the test. You'll have 2 times to take it. Takes the higher of the 2. The reason I give you 2 times is some of y'all could sink a battleship with a banana. So that's why I give y'all 2 times. So if you sink the first time, then, and please don't take that cursor off the test. If you do, it's going to knock you out. Okay. Now, homework questions. I've got a bunch of homework questions. I'm going to start them for you because I'd say 90% of these questions are the Wimbledon questions about Riemann's. And I'm going to go ahead and just go over a few of them. The actual test questions that we need to cover are the last 4 or 5 questions. I think I've got about 20 to go over. So with that being said, I'm going to go ahead and show you something else also, because I know some of y'all probably already know because y'all invented calculators. I'm going to go ahead and show you how to find the area on a calculator. Now, this is not to substitute for finding the antiderivative, Miss Hart. This is for y'all not to have to kill yourself worrying about the Riemann's theorem, because I'm not going to test you on Riemann, okay? I want you to know about it, huh?
So I don't have a calculator, so you don't have to worry about that.
Well, I don't want you to worry about Riemann. I want you to be able to say, I understand Riemann, and I know how to do it because Hubert showed me. But I'm not going to test you on it. All right, first of all, let's go to the 2-jigger here, and I'm going to give you 1 over x. F of x is equal to 1 over x. And I want you to find the area from 1 to 2. Now, if you did that by hand, by the fundamental theorem of calculus, you would do x to the -1 dx from 1 to 2. Corona. Anybody know what happened to the flu? That's going to be x to the what? Well, the antiderivative of x to the -1 is not x to the 0. It's 1 over what? 1 over x. 1 over, I meant the natural log of x. That's going to be x, yeah, plus 1. That's going to be 1 over x. And that's going to be evaluated at 1 and 2. And then you would just do 1 over 2 minus 1 over 1. And that's going to be 1/2 minus 2/2. And I've done something wrong. I don't think I have. It'll be x to the -1. I think I've done everything right. Somebody check my antiderivative. X to the -1, that should be 1 over x. I'm sorry, natural log of x. I said the natural log of x, didn't I? There we go. The 2 and 1. So that's the natural log of 2 minus the natural log of 1. And we'll do that on the calculator in here in just a second. Okay, so that would be the way I would test you. This is called fundamental theorem calculus. 5 point Hubert's homework. That's the kind of questions I'll give you on Hubert's homework. All right, that's how you do it by hand. But if you wanted to do it in your calculator to check your work or to check Riemann, you would graph 1 over x, and I've already done that. Everybody got that? Just graph 1 over x, just like you've been doing 6th, 7th, 8th grade, or about the 2nd grade when they first gave you a calculator. 1 over x, graph, and then hit second trace. And go down to number 7. And lower limit is 1. Upper limit is 2. 0.6931. Somebody take the natural, I'll do it. Natural log of 2 minus, minus the natural log of 1. I think some of y'all, that'll help y'all with the Riemann. Not really, because they want you to do all that busy work. But you can check your answers. Everybody got that? Okay, nobody's going to talk to me today. Going to do that today, huh? Okay. First question we got is, I think a few questions have come in the middle between 5 minutes, which messes me up, but you don't, I mean, you can't help it. So I'm going to see if I can pull up the right questions now. I think this is the right one. Okay, for those of you that wondered, this is number 5.1, number 11/4. This is not a test question, but it's a question about Riemann, pretty much. Suppose the interval 3 to 1 or 1 to 3 is partitioned into 4 partitions, subintervals. What is the subinterval length delta x? List the grid points. So I went ahead and, well, delta x, the first thing you're going to do is calculate delta x. So delta x is equal to a minus b, or b minus a, over 4n. And that's going to be 2 over 4, which is equal to 1/2. So your base is going to be 1/2. Base of your rectangles is equal to 1/2. Now I showed y'all how to do Riemann right at the beginning of this. You know, I did the rectangles and I told you to make sure you could do base times height. Okay, so I have went over this before. Okay, so let's just say you've got a graph in the first quadrant. Most of these will be in the first quadrant. And you have some kind of function. I'm not really worried about the function because they don't give you a function. And you've got 4 rectangles. and it's from 1. You know the first one is 1. And we go on to 3. Okay, so we'll put 3 right here. And you know you got to have 4 rectangles equally distributed. And now you know that's 2. So that's going to be 0.5. And that's going to be 2.5. I'm sorry, 1.5. And that's going to be 2.5 because of the base is going to be 0.5. Now, that's it, because if you wanted, now I'm going to show you this to go with a lot of your questions that you sent me today, because there's 3 or 4 questions that follow this same question right here. So I'm not going to go through all those questions. I'm just going to use this question and we're going to set it up. Now, there's 3 measurements on Riemann. Actually, there's 4. The 3 main ones are left, right, and midpoint. And I showed y'all that. At the beginning of the semester. Left, lavender, right, red. And I couldn't think of, can y'all think of a color that starts with M? Mauve. I don't have a mauve. Plus, I think that the mauve. What?
Magenta.
Magenta. Thank you. Let me get a magenta. I don't have many magentas. They're all dark. Well, we'll go with that one. I don't know. It may look purple. I'm looking for another.
Magenta.
Okay, magenta.
Purple.
Magenta. Somebody's going to say, well, that's purple. Okay. Now, that's magenta. That's purple. Okay. For some of you future mother-in-laws, you know, that's magenta. That's purple. Well, it looks like it. Anyway, magenta stands for midpoint. And I'm going to go ahead and tell you this one because sometimes I think of I need a color that starts with T. I can't think of one right now. I guess I'll just have to use pink. And pink, we're going to use pink for the trapezoidal. Trapezoid, left is lavender, right is red, and magenta is midpoint. Now, Riemann uses all of those, okay? The left side of the rectangle is the dominant side. So here's my left. So I draw a cross right there. Then I use this. That's left. Then I draw this. This is left. I draw this. And this is left. So my left-hand side points are 1, 1.5, 2, and 2.5. Now, it's very important that you understand what I just did, because that's a lot of these questions, they ask these, and this is tedious as far as they asked all 4 of these, you got to do all 4 calculations. So I don't have time in an hour and a half to do all of those tedious calculations. So I'm setting y'all up to set each one of them up so you can do them. All right, so if I wanted to find the area of the lavenders, which is this area, this area, this area, and this area. I'm going to find that point, that point, that point, and that point as far as the y. And I know my base is 0.5. This is 0.5. This is 0.5. This is 0.5. And this is 0.5. And what's the area of a rectangle? Base times what?
Height.
Okay, so all I got to find is these 4 points right here. And the way that I do that is that I put this point into the function. F of 1 equals, and that'll be that point right there. We'll call that y sub 1. F of 2, f of 1.5, that'll be y sub 2. F of 2 will be y sub 3. And f of 2.5 will be y sub 4. And then you take that and multiply by 0.5, that and multiply by 0.5, that multiplied by 0.5, and add them all together. And that's Riemann's theorem, Riemann's sum. That's why it's called sum, because you're going to add them all up. Because that's your base, and this is your height. Now that's on the left side. Left is lavender. So red is right. So I'm going to use this point. And I'm not going to put this in dash because I don't want you to think that's a point. Okay, that's not a dominant point. All the rights are. There's my point. There's my point. And there's my point. So my right side is going to be f of 1.5, f of 2, f of 2.5, and f of 3. And that's going to give me y sub 1, I'm sorry, y sub 1, y sub 2, y sub 3, y sub 4. Y sub 1, y sub 2, y sub 3, and y sub 4. And then each one of those you're going to multiply by 0.5 and add them all up. Remember me telling you that there's 3 ways to do the area under a curve? 1 is by geometry, 2 is by Riemann, and 3 is by integration. Y'all remember me saying that to y'all?
Mm-hmm.
Well, this is Riemann's, which is, it comes off of geometry. All right, we're going to do another one. Oh, the midpoint. Where is the midpoint? Well, the midpoint is in what?
The middle.
The middle. So that's going to be that point right there. So you're going to have to find a new x. Okay, that's going to be 1 point what? 1.25, 1.75. So if I do the magenta is midpoint, I'm sorry. So if I do the midpoint, that's going to be 1.5. Well, I'm sorry, 1.25, sorry. 1.25, 1.75, 2 point what? 2.25, and 2.75. I didn't put the right ones, so I'm gonna put the right ones right now. The right midpoint, the right coordinates are 1.5, 2, 2.5, and 3. I'm writing on 2 pages, but I'm not going to mess with it right now. Now, the trapezoid, we're not going to go into that. I just want you to, you'll see it. I'm not going to worry about that right now.
Priority 1 message coming in on secured channel.
You just use the area of the trapezoid.
Priority 1 message coming in on secured channel.
Sorry, I don't know if that's, no, as long as it's not my daughter. Thought something was wrong. Okay? Well, yeah, people can, yes, trigonometry, you can use trigonometry and geometry to find the area under anything, but it will take you a whole lot of time and a whole lot of detailed math. Calculus does away with all that tedious math. Teal, that's the color I was thinking of, teal. Oh well. I'm only behind a little bit with the conversations that are coming up on my phone. All right, so that's how you do these. You got to draw a picture, and you got to draw it big enough to where you can write on it. If you don't draw a picture, you ain't gonna know what you're doing. And I guarantee you, people that have some of these questions, I guarantee you they didn't draw a picture, or they didn't draw it big enough. Now, I don't know who sent these questions. I don't look at the names. So I'm not making fun of you. I'm just stating the fact. And you better get used to drawing these things, because when you get in statics and dynamics, well, actually physics, statics and dynamics and thermodynamics, you're going to have to draw free body diagrams all the time. All right, so let's go to another question. And like I said, most of these questions are coming from 5.1, 5.2. And
yeah, you should do away with the.
yeah, that one is one that just, let's see. Yeah. This one is not a test question. It's just another, I believe you can actually view them right here. Yeah. So the first thing I would do, and the first thing I do, is I'm going to draw a picture. Okay, so the first one says, divide the interval 1 through 5 into subintervals n is equal to 4. I think it says n is equal to 4 somewhere. Does it not say n is equal to 4? Yeah, I think that's the 1, 2, 3, 4. Yeah. And then, oh, you do 4, but okay, you get that, yeah. And then n is equal to 8. And if you don't want to draw them, which I would not, I would take those two and I would draw them real big on your paper right now. Draw 1 page for this one, or half a page for this, and a half a page for this. So you'll have a half a page to do the calculations. 2 pages right here. That's what I'm fixing to do right now. So I'm going to take my handy dandy page, and I'm going to draw.
Priority 1 message coming in on secured channel.
Well, since I don't have,
Priority 1 message coming in on secured channel.
I'm going to draw right here. And the picture, you can take your calculator and do 2t squared plus 1, okay? But you really don't need that, because you know you have a y-intercept of 1, and you know that it's going from 1 to 5, and you know that that 2 is a very skinny parabola. So it's looking at something like that. But if you don't learn your family of graphs and you don't learn your vertical and horizontal shifts in algebra, then you don't know how to do that. Okay, so 1 to 5. So there's, I'm going to put 1, 2, 3, 4, 5. And of course, I can't get mine, so I'm gonna cheat a little bit. I'm gonna make mine look like that. Okay. All right. So I'm going to just draw a dashed line from 1 to 5. And I'm gonna, like I said, I'm gonna set this up to where you can do it each way. So lavender means left. So I'm going to draw a left line up, and then I hit, and I go over. Left line up, then I go over. Left line up, then I go over. Left line up, and then I go over. So I should have 4 left lines. Left 1, left 2, left 3, left 4. So I'm going to use my left, my X's for my left. Left X's. 1, 2, 3, 4. So those are the X's you're going to use in your function. So I'm going to go down here, and I'm going to draw another graph. And I'm doing this just for, y'all. You don't have to do this with each problem. Make it a little bit wider there. 1, 2, 3, 4, 5. And this is going to be right. So I'm going to do red. I'm not going to start with 1 because I got a dashed line there. Let me put that black dashed line here. Okay, now I'm going to start with the right side. And I'm just drawing this dashed red because I don't want you to think that that's the left side, and I don't want you to think that's dominant. So my right side X's two, 3, 4, 5. Now, if n is equal to 4, which it should be, how many X's should you have? 4. How many Y's should you have? 4. Midpoint, you'd have 4. What would the midpoints be? The midpoints would be 1.5, 2.5, 3.5, and 4.5. Now I'm going to put that in mauve. I'm just going to put the dots. 1, 2, 3, 4, and that would give you, and that would be a line across there like that. And the midpoint, I'm going to put them down here. Midpoint X's would be equal to 1.5, 2.5, 3.5, and 4.5. And you plug them in to the Y's. Now we're going to do the first one, and then y'all can do the other ones for homework. Work on them yourself. So I'm going to go back to the lavender, and my function is 2t squared plus 1. f of x is equal to 2t squared plus 1. So that's going to be 2 parentheses squared plus 1, 2 parentheses squared plus 1, 2 parentheses squared plus 1, 2 parentheses squared plus 1. 1, 2, 3, 4. So 1 squared times 2 is 2 plus 1 is what? 3. So that's that point right there as far as y. Okay? 2 squared is 4 times 2 is 8. 8 plus 1 is what? 9. So that point right there is 9. Y equal to 9. Y equal to 3. 3 squared is 9 times 2 is 18 plus 1 is 19. Y'all check my math. So that point right there, y is equal to 19. And then the last one, 4 squared is 16, 16, 32, 33. So now you want the area. So it's going to be 3, and the delta x is 1. The width of the boxes, delta x is equal to 1. And if you ever want to calculate it, 5 minus 1, delta x is equal to 5 minus 1 over n. So now I'm going to take 3 times 1. Nine times 1, 19 times 1, and 33 times 1. So when you've got a delta x of 1, do you really have to go through and multiply the length times the width? No. You just add them all up. And that's going to be 33 plus 20 is 53. That's 52. 52 plus 10 is 62. Plus 2 is 63. So I get an area of 63 square units. And it will be under. Why will it be underestimated? Because your areas of vapor or gas right here is nothing, is under the curve. So it's going to be underestimated. Underestimated. And of course, this is going to be, the right is going to be overestimated.
Priority 1 message coming in on secured channel.
And usually the most accurate is going to be the midpoint besides the trapezoidal. This is usually the most accurate. Why? What's the reasoning theory behind it?
The
Why
over?
is the, huh?
The over or the?
The midpoint is the most accurate. Why is the midpoint the most accurate?
Because you don't have that little spaces everywhere.
Because basically you're taking the open space, the under space, and canceling out the what? The over space. And that's basically giving you a more accurate.
Yeah, you know what I mean.
Yeah, the reasoning is there. You just got to think about it. Okay, so that's how you find, I found that area. Now you do the same thing down here. Well, that's going to be f of 2. You got f of 2 right there. That's 9. And you can copy most of this. See, that's 9. That's what? 19. And that's what? 33. So now you just got to copy this. You got to calculate that one. So 5 squared is 25. That'd be 51. Now, again, so that's going to be 9 times 20 is 29, or 9 plus 20 is 29, plus 30 is 59, minus 1 is 58. 58 plus 50 is 108 plus what? 4? 112? I think I did that one wrong. Somebody add those up and tell me what you get. 9 plus 19 plus 33 plus 51. What do you get?
It's 112.
It's what?
112.
Square units. Now you can see that it is a little bit overestimated. And if you were to do, I bet you'd get, say, 112 plus 63 is 175. Half of 180 is what? 90. I guarantee you'd get between somewhere around 90 something units, square units, if you did the midpoint, because that's the average of these two. And all they're doing is trying to get you to reason with the geometry under the curve. That's all they're doing. They're trying to get you to think about how to find the area under a curve using geometry.
Priority 1 message coming in. Priority 1 message coming in on secured channel.
Oh my Lord. That gum kids. Okay. I don't know why I had them in the first place. All right. So that'll take care of that. Now, what about the 8? Well, now you got to divide by 8. So you take that same picture and you make it bigger. Why? Because you got to see it better. So there's the 1, or what it is crossing at 1. And you're not going from 0 to 8. You're still going from what? 1 to 5? So 5, let's find delta x. Delta x is equal to 5 minus 1 over 8. 4 over 8 is what? 1/2. So now you got to make each one of these, rectangles a half. Well, we know this is 1, right? And this is 5. I'm sorry, you don't see it. Oh, me. There we go. So now, well, let's go ahead and say this is 2. This is 3. And this is 4. And of course, it's not by scale, but it's good. It's big enough to where you can see it. And now I'm going to put a 1.5, a 2.5, 3.5, and a what? 4.5. And now I'm going to take my handy dandy orange and I'm going to draw these are not dominant lines, these are just lines. How many rectangles do I have? 1, 2, 3, 4, 5, 6, 7, 8. It's a miracle. And now I'm going to draw the left lines with my, so this is going to be my dominant. 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 And this is going to be my dominant. Y sub 1, Y sub 2, Y sub 3, Y sub 4, Y sub 5, Y sub 6, Y sub 7, Y sub 8. Now I'm going to draw red. I'm going to draw my right. So it should be right there, sorry. So that's going to give me your y's. This one's going to be y sub 1 all the way up to y sub 8. And of course, if you did your midpoint, I'm only going to do the first couple. Your first couple, that would be 1.25. And that would be 1.75. 2.25. That's 1.75, sorry. So you see that there's absolutely no calculus in these problems whatsoever. There's nothing but theory and reasoning behind these problems. That's it. And your basic area of a rectangle is equal to base times height. And to get your height, you have to know what this function is. So you can plug either the lavender numbers in, which is going to be 1 and 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. So I'll highlight the, I'll put a single line under those because those are left sides. And then I would plug in my right side. I'll do that double red. And you'd plug those numbers into your function. Of course, if you did the midpoint, you would plug the midpoints into your function. Okay? I'm trying to get through these as fast as I can. There's a lot of them. I don't know why that won't go away. Okay. Looks like 15. Did we just do that one? Yeah, we just did that one. So that should answer yours, Mr. Prebeck, and I think Ms. Hart might have sent that one and Ms. Patel. So that'll help all three of y'all. Okay, 5.1, 27/8. Okay, this one is not, somebody sent that one right before class, I believe. Hold on a minute. I want to see. I'll have to come back to that one because I've already got these done and I'll have to come back to those for tomorrow. Okay. 5.1, 44/12. You know what I did on this one? I put it in a Excel spreadsheet. Now the Excel spreadsheet drew the blue line. And if you draw this, you're going to know what to do. So I'm going to show you what I did. And the only reason I'm showing you is I want you to see what it looks like without the lines on it, or without my lines on it. So there's my Excel PowerPoint. I'm at my Excel sheet. I'm gonna make it small. And I'm gonna punch those in. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5. And then I'm going to plug in 3, 5, 11, 18, 24, 36, 30, 15, 8, 4, and 1. Highlight it. Insert. And I just did a line graph. And you can blow that up and you can hit right click, copy, open up the word processor. Layout, landscape, margins, none. And it's a miracle. Now, after you do this, then you can go and do this. And there's my left-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got my left hand, I'll do that in lavender. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. Those are my left-hand coordinates. Right-hand coordinates. Right there. Those are your right-hand coordinates. And notice I didn't put a left-hand line there. I just put a dashed line because your dominant line is your right line, your right-hand side. So these are your right-hand number, your coordinates. And that should be, you know, and like I said, a lot of people, when they see this problem on a test or homework, what do? They just sit there and stare at it. Okay? But if you draw a picture, makes all the difference in the world. Let's see. Let's do a left hand. I'll do the left hand, and y'all can do the right hand. Although I guess they're asking for the left hand. Here is your picture of my left hand. We know our points are right here. We got our points. There's our points right there. So let's make it small. These are your Y's. Hold on. These are your Y's right there. So really, you don't have to do much. All you have to do is do, okay, each one of my bases is 0.5. So that's going to be 3 times 0.5. 5 times 0.5. 11 times 0.5. 18 times 0.5. 24 times 0.5. 36 times 0.5. 30 times 0.5. 15 times 0.5, and 8 times 0.5, and 4 times 0.5. Now, why aren't I using that last number? Because it's not a left-hand number, it's a right-hand number. So now I just do 1.5, 2.5. Oh, I'm sorry, I'm supposed to be using a calculator, aren't I? What's that, 9, 12, 18, 15, 7.5, 4, and 2. 1.5 plus 2.5 is what, 4? 9.5, 18.5, so I'm going to just say 18.5 there. 18.5 and 7.5. 18.5 and 7.5 is 26.
It's
So that's going to
77.
take that out. 26. 26 plus 9 is 35. So that's going to take 30. I'm wanting to do this by hand. I'm trying to prove a point. 30, thank you. 35 plus what? Well, that's 30 right there. 30 is 65. 65 plus 15 is dang old 80, right? 80 plus 6 is 86. I got 86. What'd you get?
It's 77.
Okay, well, I must have did something wrong. Okay. But that's how you do it. Do the red the same way. You just do the right side. So it's going to be half of 10, half of 15, half of 22.5, half of 35, half of 22.5. I have no idea. Half of 15, half of 5.5. I have no idea. And whatever I'm just 4, half of 5 and half of 2.5. So that 5 right there, that you're going to use that 2.5 or whatever that is right there. 1, I'm sorry. 1. You're going to use that. Okay, they got 73 and 72, so you'll have to check your math there. They got 73 and 72. Again, this is not test questions. This is, like I said, this is questions about Wimbledon and who showed up and what were their addresses. Okay, next question. That was 44. That was 44 slash what? That's 44. So that will take care of these 3 questions. Hopefully that'll help Hart, Prebeck, and Woodall. Does that help y'all? I hope it does.
It'd help me more if you just got rid of all of it.
I heard
I'm
that.
sorry, what?
I said it would help me more if you just got rid of all of it.
I know. Yeah, I would if I knew that they weren't going to ask y'all, you go over Riemann's theorem in Calc 1? So,
Wasn't the Riemanns in your homework?
yeah, it's in the 5.1. All 5.1 and 5.2 is Riemann.
Yeah, but is there none in your Hubert homework?
I didn't put any in that. No.
Oh, okay.
All that is finding the antiderivatives.
Gotcha.
All right, 5.162 slash 15. This should be the one with sigma on it.
It is time, by the way.
Okay, let me finish this one. This one is just a multiple choice. Whenever you're wanting to do the left-hand side, I'll just go ahead and show you. Whenever you're doing the left-hand side, as far as algebraically, here it is. There's the left-hand side. So you're going to have a K minus 1 in there, and that's where you get the K minus 1 with your answer, D, okay, because of that K minus 1. And then you plug that in this. No, you are not going to be tested on this, okay? And that's going to give you this. And a lot of you say, well, how do you get delta x? Well, delta x on this one is real simple. Delta x is real simple because you don't have to actually do any math. You just take the natural log of 2 minus 1, because natural log of 2 minus 0, minus 0 over 50. And that's going to be natural log over 50. And that's the number, and that's the number. And you're going to plug 50 into that. So that's going to be e to the 49th power times a number, all that times a what? Times another number, which is going to be the same as this one. And that's going to spit out your answer. K is 50. So 50 minus 1 is 49. This is what you're doing when you're not doing geometry. This is basically Riemann algebraically. The whole point of showing you the geometry Riemann and the algebraic Riemann is so you will appreciate the calculus. Just like the difference quotient was trying to get you to understand how good calculus is with doing the derivative. You don't have to do the difference quotient. Okay, I'm sorry, I'm taking y'all to, all right, that's going to take care of 62.
I'm bursting into flames over here. I'm exploding.
Okay, you're exploding, all right. Well, that means your brain's working. All right, so, well, do not, and I mean this with all sincerity, do not, I'm going to write this down. Do not stress over Riemann, okay? If I even spell it right. Oh, I don't know, M-A-N-N. Do not stress over Riemann. All I want you to be able to do, if you can do Hubert's homework, that one homework session, if you can do that homework that I gave you, then you can do the test. Okay, and just try to do the best you can with me answering these questions. And I've got another, right now, I still got another 7 or 8 questions, homework questions to do. So that'll be tomorrow's class. All right, so let me do handy dandy attendance tracker. Oh, I've got to cut off the do-jigger. Cut off the recorder. And that's that.